Your units. With that said, why don't we take a look at a somewhat similar problem? Let's talk about quoting. Let's take a look. Here's the premise. I have some program that takes some flags. And so here I have a simple Python program, test.py. And it takes some flags, it takes some options, it takes some arguments. And I actually don't want to use this program directly, because this might be some test for some software that I manage, some hardware that I manage. I want to write a shell script to automate calling this program. I like that the program exists because every so often somebody wants to run this thing manually. Maybe if a test fails, they want to narrow their view just to this one failing test and run that manually over and over and play with some of the arguments. But in many cases, I want to automate the running of these tests. I want to write a simple script that just calls this thing with different known arguments. So I'm going to write a script that helps me automate tests using that test.py. And my script is going to be very simple. It's going to just go through all the different permutations or the Cartesian product of all of the options here. It's going to call this script with that flag and without that flag. And it's just going to do that in a simple loop. And it'll allow me to maybe run across many different test cases. It's a very simple shell script. Even my colleagues who maybe don't have enough familiarity with Python can still more or less kind of work their way around shell scripts. Because as you know, many of our colleagues, especially those who are in QA or in testing, already have quite a bit of familiarity with using the command line and using shell scripts. And so this is a nice starting point for me in automating this simple test without having to reach for a fully fledged test automation framework. Now, having said that, there's one little catch. This particular test has some modalities associated with it. And some of those modalities, like that flag, are things which I want to control from the outside. So I want to run with the flag and without the flag. That option, and I want to say, okay, run that option with the option set to 1, set to 2, set to 3, whatever the case may be. But this thing may have some other options. And I may not be certain exactly whether or not I should assume those as being turned on or off when somebody runs the test launcher. In fact, it may be the case that some people who want the test launcher want those flags enabled and other people don't. And I don't really want to make my test launcher that complicated. I don't want to write two versions for the people who want it and the people who don't. Maybe there's an extra stress test that's involved here, and maybe that option is engaging the stress test. And some of my QA people don't do the stress test because it's very time consuming, but some of the other QA people who maybe have a longer time horizon for the things that they're testing do want to do the stress test. And so I want to leave that option there, but I want to leave it for whoever's running the launcher to choose whether to include it or not. And so what I'm going to do is something that's very subtle, but also very clever, and also absolves me of a lot of design responsibility that I don't want to take on. What I'm going to do is this. I'm going to structure my script to take two different types of arguments. The first argument that it's going to take is arguments that are passed directly to this test.py, the thing that is going to be tested on, the A, the B, the C, whatever the case may be. It's going to take that at the command line. The second thing it's going to do is it's going to take extra arguments that are past this test.py. It's going to take two different types of arguments. And I'm going to use a little trick that you'll see throughout the design of common programs where you have programs that happen to launch other programs. I'm going to distinguish between these two types of arguments using a double dash. This is a thing that comes up very, very often. Here's an example. When you have the rm command, that rm command takes all sorts of flags, -f for force, -r for recursive. Well, what if you wanted to delete a file whose name happened to be -r? Do you do rm-r-r? How does rm know that that's one file called -r and an argument that happens to be the -r argument? It doesn't know. Maybe you want to delete the -r file. You were so insistent upon deleting it because you couldn't manage to delete it yet. You want to delete it twice. rm doesn't know. So what rm will say is specify all your flags and then put a double dash. And then after that double dash, I know for certain everything that comes is going to be an actual file name. So in this case, you would do an rm -r. We're going to use the same kind of trick here. So we're going to read in all of the command line, all the arguments that are passed on the command line, and we're going to look for a dash dash. And when we see that dash dash, we're going to say, okay, everything after that was one of the targets, like what kind of test to run, or which test suite to run, what the name of it was, whatever the case may be, in your use case. And everything before that is going to be one of these flags that we pass in. Except some of these tests might be just a little bit time consuming, so we're going to make this shell script just a tiny bit smarter. I want this shell script to have a dry run mode so that before I launch off a test that's going to take me through the entire lunch break that might fail, and then, I just took an hour and a half lunch and I'm coming back and this thing failed and I'm going to have to stay late. What I'll do is I'll add in a dry run mode. I'll collect the commands that this command runner is going to run in an array, and then if dry run is turned on, I'll just print them out to the screen. If dry run isn't turned on, I'll actually use eval in order to evaluate them. So I have a simple script that looks like this, and in one mode, it'll actually run them, in the other mode it won't. And I can do all of this in direction, very useful in direction too, because I can kind of check to see what it's going to do before I do any work. Well, I can do that in just a couple of lines of shell. Shell is an amazing tool for doing powerful things in very, very little code. Except when I deploy this thing to production, it's going to blow up in my face. Can you spot the error? And I'll give you a hint. Well, what about if there's spaces in the flags? Is this going to work? If one of the flags takes an option and that option happens to be a file name and that file name happens to be a space in it, will this work? Did that hint help? Well, you're absolutely right if you said that this code is more or less the prototypical approach that we would take in order to set up some kind of command runner that first collects what it's going to do and then runs what it's going to do. And that this pattern of first collecting the actions we want to do and then running the actions that we want to do is generally a pretty nice one in practice. Everybody loves to be able to see what the script will do without having to run that. It just makes everybody's life easier because we have a lot more confidence that the script is going to do the right thing. So I think the pattern itself is valid. I think the construction of the commands themselves is not quite valid because here what we're doing is we're constructing a giant string by just pasting in what we were passed at the command line without taking care to make sure that those things have been quoted if they need to be quoted. We are storing the flags and the targets in an array, making use of an out-of-band encoding in our, in this case, Z shell program. And so we're doing that correctly. But when we turn that back into one string to run, well, we gotta reverse this process of figuring out how to split up what was passed in the command line into individual argv, read those into an array that maintains that distinction properly, and then create something that is equivalent to what was typed at the screen. And this is exactly the nature of this problem, and exactly something that comes up quite often anytime you have this level of indirection. Create something which will then be run via eval. I will tell you that even if this seems a little bit far-fetched, it is not that far-fetched. Think about commands like SSH, where you can sometimes SSH into a machine and then just run a command, and some of the weirdness that happens when that command happens to need things which include quoting and making sure that that's correct. Well, the answer to this particular problem is to make sure that we are properly constructing the resultant string. Here, we're going to make use of some features that are available in our Z shell in order to do this. We're going to make use of expansion arguments that are provided to us for the shell. So what we're going to do, we're going to take the flags and we're going to go through each one of these flags and we're going to quote them. Q means quote these. So we're going to tell Z shell, you know what? You know how to interpret this thing. So you know how to take something that I typed and break it up into individual arguments by quoting these. You should know how to do it the other way around. And in fact, our Z shell knows how to do that. The dash here just says, take an easy hand on this. Don't add lots of quotes even if you don't need to. So only add them in places where you need to. We'll take each one of our flags and we'll quote them. And then what we'll do is we'll take that array and we'll just space join it. And this should give us something which we can then pass back to Z shell to run. Let's see how this works in practice. If we were to run this particular script with, say, some other option, and this were to have an A, B, C, D, E, F, you can see our ABCDEF is correctly pulled into our script as one argument, not two. Whereas, if we were to have done this with our first version, we'll see that, let's do that one more time. Our ABCDEF appear to have been correctly passed in, but if we turn off our dry run mode and we actually run it, we'll see that the ABC was set to other, and the DEF was interpreted to be another argument. So we always have to be kind of careful about making sure that we round trip these things. But in general, we can do these, and we can do these safely, making use of tools that are available in our Z shell. Well, I want to explain some of the concepts behind this, because as always, the concepts in the mental model are always more important and more interesting than the one particular example of what we're looking at. Here's how it actually works behind the scenes. When you're at the command line, you're typing, program, and then some flags that are passed to it, and maybe here you have something like this. So you're going to run this program on arguments A, B, and C, 3 arguments there, plus 1 argument X, Y, and Z. Well, your shell doesn't have any implicit or inherent understanding that this is not just one string that then needs to be split up by its own mechanisms. That is to say, the splitting of arguments at the command line is not something that is any deeper than a mechanism that the shell is using. So what the shell is really seeing, what your Z shell is really seeing when you type this is, it's seeing somebody typed this as one single string. And then the shell is applying its own logic to say, okay, now let me parse this into something like this. The shell is going to do this parsing, and then the shell is going to make use of some system call like exec_ve. If you look at the system calls for executing a process, at least on Linux, there's actually a variety of these. There's exec, there's exec_v, there's exec_ve, there's exec_vpe, and the letters here just mean what variation you're using. V means pass the argv as a vector. Pass it as individualized items, not as something which is then going to be interpreted by another layer. VE means use or allow us to pass an environment. So you can pass environmental variables as well, so you can kind of cascade environmental variables down. And VPE means use the path to find the executable you're going to run. So oftentimes you can think, well, exec_vp has got all of the features we want. We'll just use that. So we'll focus our attention there. What's going to happen is the shell, having parsed this using its own logic, which is specific to your shell, but most POSIX shells follow the same general quoting practices. It's going to say, okay, I'm going to call something like exec_vpe, and I'm going to pass, usually the way it looks, it's going to do something like this. It's going to pass the binary, which will then be found on the path, and then the argv, the arguments that are passed in. And it's going to pass this in a C array. Here, this kind of looks like Python code, but it's going to pass it in a C array where that C array is unambiguously distinguishing where one argument ends and the next one begins by encoding this as a double pointer to basically null terminated strings. This is then going to be picked up on the other side, probably by something that maybe starts with, a glibc style starting point. And that's going to look kind of like this. And even your Python interpreter is going to basically start with something like this and then pass that into a Python data structure for you. And here you can see you have each one of these arguments uniquely and unambiguously distinguished. And so here in Python, this will do something like your PyMain, whatever, and it'll pass this as a Python list. And so in your Python code, you'll have something like this, an argv, and that argv will have these arguments unambiguously structured. Well, the general idea to making this work round trip, to making it so that your shell can then take something in, parse it out, and then regenerate something is to tell the shell how to redo the process of quoting these that it undid as part of its parsing. And in things like Z shell, what we have are mechanisms like this. If we have an array, and here I'll call this args, that has A, B, C, and X, Y, Z. Let's make sure this thing actually works the way we would expect it to work. So here, we'll say the size of args is this, and we'll see if this is really how big we expect this thing to be. So here we expect this to be 4 entries. A, B, C, 3 entries there, and X, Y, Z, 1 more entry. And here we'll, of course, have to quote these because otherwise, and we'll have to quote that as well. Otherwise, that'll be, there we go. And here we've got an equal sign. There we go. So 4 arguments. Very good. And if we wanted to see what these individual arguments were, we could use the same little trick here. You know, writing something like this, but not operating on the argv, but operating on the $@ the argv. It's a nice little shell script that you may find that you want to write to debug all of the shell scripts that you write, because it's a little helper that tells you, oh, I actually did split these up properly, or I didn't split these up properly. Well, what we want to do is we want to tell Z-shell to re-quote these. One of the ways we can re-quote these, if we really have to, is we could iterate through each one of these entries. We could manually re-quote them by manually doing string replacing, you know, to replace things that we have to, like single quotes with, you know, a close quote, single quote, open quote, and whatnot. Or we can ask our shell to do some of that quoting for us. And you can see when I do this, the shell properly quotes each one of these in exactly the way that you would have to quote this if you wanted to pass as the command line. Well, there's a couple of different options for this. We can choose to use double quotes. We can choose to use the most minimalistic style of quoting, just whatever is visually easier for us to do. And our shell gives us the ability to take this result and to do things like join these up. So what we'll do is we'll join these strings up into one string, which quotes any of the individualized entities where the space separation would not adequately represent that this is where one entity ends and the other entity begins. And this is what we pass through. So it's just this general process. Now, I know that all of these symbols, sometimes they make your head spin. The @J, the @Q, but here's really the lesson that I want you to learn. A lot of the mechanism for solving the common problems that you have exist in your more advanced shell. Maybe not in your Bash version 3 from 10, 15 years ago, but in your most recent versions of Bash, your most recent versions of Shellshed, these solutions exist. Fundamentally, however, you're not really going to go and read the man page for Z-shell or the man page for Bash because it's really long and it's really boring. Instead, what you're probably going to do is you're probably going to want to write very small prototypes. Anytime you identify something that just doesn't seem to work that well or doesn't seem to fit the mental model that you have or a bug that you didn't anticipate, I strongly encourage you, write tiny prototypes in Shell and work iteratively. Simple tiny prototypes to solve the problems that we've seen so far include things like a prototype to make sure that you've correctly identified, you've correctly requoted or correctly parsed an argv. So a simple prototype that doesn't look like this, but looks extremely similar. That's just the same thing, but operating on type set A, args equals operating on whatever arguments were passed in. And then you can use this in conjunction with any other tools that you're writing to make sure, oh, did my helper tool correctly pass things down the line? In general, one of the things about how Shell works is it is a tool that you use for taking small units of computation, small opaque units of computation, and building them up into larger automation. So the approach with Shell is you started with one little command, and then you piped something into that command, and then you put that into a loop. And then you put that into a shell script. And then you had this shell script call that shell script. And in the end, the small little incremental unit of computation was called maybe 4 shell scripts deep with all sorts of mechanisms. Well, the way you keep yourself sane when you do this is build small prototypes and make sure that each next step is done correctly. So build these prototypes, and every time you add one more layer on top, just check with your prototypes, did I correctly handle passing the argv? Did I correctly handle issues with file names and quoting? And if you do that, what you'll discover fairly soon is that those small prototypes will guide you to maybe not a 100% correct shell solution, but a 99% correct solution. I can't say that you can get to 100% correctness with just this approach, in part because you do have to deal with maybe you're deploying to a machine and its version of Z shell or bash is really out of date, or maybe you're deploying to a machine and you think that it's dash and it's actually ash. Those differences do exist. Maybe you're deploying to a machine and they have a buggy old version of something. Those are things you do have to deal with. But at least within the constraints of, you're deploying to machines that look very similar to your own machine, just operating on data that may look very dissimilar to the test data that you used, you can get really, really, really close to a perfect shell script just with that small incremental approach. And so our conclusion here is work incrementally. Build small prototypes. If you write anything more than one shell script in your entire life, you should have at least a tiny prototype to check that your $@ is being passed, parsed, or generated correctly. Don't shy away from structures like setting a command with a dry run flag, just because this gets a little bit hairy if you don't work incrementally, because those structures, that indirection, having a dry run flag is a fantastic helper to make sure that the script is doing what it's supposed to do and to give people confidence in the way that this works. Don't shy away from those. Learn how to make use of the shell better, and rather than exhaustively understand how the shell works, approach this incrementally via very small prototypes.